Frisbee, are you good at throwing one of these? It's great when you can throw a perfect arcing curve right on target. If you can do that, you have already trained your arm in the art of aerodynamics. Aerodynamics explains how air travels around the things that move through it, like a Frisbee. In today's lesson, we're going to learn a little bit more behind the science of a Frisbee throw, and then we're going to construct our own Frisbee using our understanding of geometry. Are you familiar with Frisbee golf? It's also called disc golf, and you can play it pretty much the same way that you do regular golf, except you use a Frisbee instead of a ball and a club. If you're interested, I put a link in the Google Classroom in case you want to find out more about Frisbee golf and how to play it. You can see me throwing it at different angles here. The angle at which you throw the Frisbee affects its flight direction and distance. Two key aerodynamic forces that act on a Frisbee during flight are lift and drag. Lift is the force that allows the Frisbee to stay airborne. When the Frisbee is in flight, lift counteracts the force of gravity for a little while, so the Frisbee doesn't immediately fall to the ground. The Frisbee itself creates this lift force as it flies through the air. Because of the Frisbee's curved shape, the airflow above it must travel at a higher velocity than that underneath, thereby creating low pressure above and high pressure below the disc. This pressure difference provides the lift. The other force is drag, which is like resistance. When you throw the Frisbee, as it pushes forward, you're actually fighting against the drag, which tries to push it backwards. If you were to throw a Frisbee vertically, like this, here's a Frisbee thrown vertically, it wouldn't go very far because there's so much surface area here and the air pushes back on it. When you throw it horizontally, you cut down the amount of drag that it goes through in the air. Here's a Frisbee thrown horizontally with spin. And you've probably noticed that a Frisbee does not travel very far unless you put some spin in it. Spinning the Frisbee helps it to fly by supplying angular momentum, which helps keep the Frisbee stable. The faster it spins, the more stable it should be. Here's a Frisbee thrown horizontally without spin. And here's my best throw with spin. And one final tip for the perfect Frisbee throw is that when you toss it off, you kind of want to point your finger in the direction that you want it to go and have it slide off of that finger. If you do that, the Frisbee should go exactly in the direction that you're pointing. For today's activity, you're going to need to know some shapes. You have to know square, rectangle, right isosceles triangle, parallelogram, and octagon. To make your own Frisbee, you are going to need a few pieces of paper, scissors, a pencil or something to write with, a ruler, tape, and this is optional, but if you have a protractor, that will come in handy. All right, first thing you're gonna do, you're gonna take 2 sheets of paper and you're gonna cut them into 8 by 8 squares. 8 by 8 for both of them. 8 inches here. I'll put it on the side too, so I can draw a line across. 8 inches. Okay, now I'm gonna connect that with a line. It's about there. Okay, and then across, most paper is 8.5 inches, so we're just going to take off a little bit. We're going to put a mark there at the 8-inch mark. And I'll do the same thing where I put a few marks on there so I can draw a line. Okay, I have my 3 marks here. Now I'm just going to put my straight edge on it, draw a line. Okay, I have my lines here. I'm just going to cut out the lines now. Okay, and since I did 2 at once, now I have 2 8x8 sheets of paper. What I'm going to do is I'm going to stack them together again, and I'm going to divide them both into 4x4 squares. I'm not going to cut anything yet, but I'm going to draw a line here and there. Okay, there we go. Those are 4x4 squares. Now we're going to cut along these lines, and you should have 8 squares by the time you're done. Okay, so now you have a bunch of squares here. Some of them are stuck together. There you go, you should have 8. Now take one of your little 4x4 rectangles or squares and fold it this way, hot dog style. Try to get it even. Okay, and then fold it hamburger style. Put a nice crease in there. Should look like this. Okay, now take this shape, unfold it like that, not all the way, just like this. And then look at this crease here. You're going to take the bottom left corner and you're going to fold it up along that crease. If you need to, put a line there so you can see it. Fold it up right along that crease so it's perfectly in line with that crease. And put a, okay. This is a right isosceles triangle. Now take this corner and fold it down right along that same line. Nice and even. And that will give you a parallelogram. I don't want my parallelogram to come undone, so I'm going to take a piece of tape and I'm going to put it right down the center.
That should hold it in place. Okay.
Now do it 7 more times. So for every square that you made, you're going to do the same thing and turn it into a parallelogram. Count them, make sure you have 8. Now we're going to form an octagon with all 8 of our pieces here. And in order to make that octagon, we're going to put these together. Whoops. And you're going to be able to slide them in kind of like that. But now I want to show you the geometric part where we're going to find out the angle necessary to put these in. This is the formula for angles of a polygon. All right, n minus 2 in parentheses times 180, and n represents the number of angles. So for an octagon, how many angles do we need? 8, right? So that means n is going to be 8. So let me plug that in. This will turn into 8 minus 2 in parentheses times 180. Okay? And let's solve that. 8 minus 2, we do the parentheses first, so 8 minus 2 is 6. Times 180, 1080 degrees. But we only need to know one angle at a time. So we're going to take that 1080 and we're going to divide it by our number of angles. 1080 divided by 8 equals 135 degrees. Okay, so that means each angle will be 135 degrees. If you have one of these, a protractor, it shows you where 135 degrees is. It's between 140 and 130 there. So that means the bottom edge is there, and then the side of the angle comes up through there. The angle is going to look about like that, 130 degrees. It's definitely going to be an obtuse angle. And if you can't put your things together exactly at 130, actually 135, my mistake. 135 degrees. If you can't do it exactly like that, just get it as close as you can so it's looking like this angle here. So there we go. If this is the bottom, 130 is about like that. Yeah, that seems about right. And continue putting these together, trying to make it about a 135 degree angle on each one. until you've gotten all 8 together in an octagon. All right, I've got them all together here. My angles kind of came out, but that's all right. I'm going to put the last one in here. Try to get it all together. And once I have it like this, I'm going to reinforce it with tape and just sort of shape it so it looks like a nice octagon before you tape it down, because once you tape it, there's no turning back. All right, now you have yourself an octagonal flying disc, and it's ready to go. You can fly it as is. If you want, you can cut out a circle of paper and then tape it over like that, and maybe that will help to reduce some of the drag. I'll try that. Enjoy your Frisbee!